So if you look around you, everything you see is three-dimensional. You can feel it, you can see it, you can touch it. So what does that mean? That means that they're made of something. That means that they're made of matter. Now this matter, we will call these pieces of things, we call them particles. Everything around you are made up of particles. So what are these particles? What are they made of? What are they chemically composed of? Now the very smallest of particles that we just cannot break down into further pieces or smaller particles are called atoms. In some substances, the particles are single atoms. For example, neon gas. What is neon gas? It's a noble gas. Now, what is a noble gas? You will learn about that later. But for now, you need to know that in neon, it exists in the natural state as single atoms, as a single neon atom will exist. It doesn't need any other particle with it or any other atom with it to exist. In other substances, some of the particles are made up of more than one atom. For example, hydrogen gas. You all know hydrogen, I'm sure you've heard the name. Now, what is hydrogen gas? It exists in dual atoms. It exists in molecules. A molecule is a particle that is made up of more than one atom. It can be made of 2, 3, 4 even. It can be made of larger numbers. Hydrogen here exists in two atom molecules. So what that means is there's two atoms of hydrogen in every molecule. So that's why in the natural state hydrogen exists as H2. Now some particles contain a charge. These particles are called ions. You will find out more about these types of particles in later chapters. Now that we know what matter is made up of, which is particles, atoms, if you may, we need to know the kinds of states of matter that can exist. Now, thankfully for us, it's a simple number. It's 3. You've got solids, liquids, and gases. Now, what's the difference between a solid, a liquid, and a gas? Okay, we start with a solid, the easiest one. A solid is a fixed shape and a fixed volume. It doesn't flow. A liquid, on the other hand, flows easily. It has a fixed volume, but its shape changes. It takes the shape of the container you pour it into. A gas does not have a fixed volume or shape. It spreads out to fill its container. It is much lighter than the same volume of solid or liquid. Now these states of matter are interchangeable. What that means is that a substance can go from a solid to a liquid to a gas by undergoing certain processes that facilitate changes of state. Some examples are boiling, melting, evaporation, and freezing. I will be explaining to you the changes of state in a more in-depth manner in coming videos, but for now we move on to a heating curve. So when you want to show a change of state on a graph, you're going to show it with reference to temperature. So if you have a graph of temperature against time of a particular substance, say supposing ice. So we show ice being heated from 0 minutes up until whatever time you require. You will first see, once we start heating the ice, you will see that temperatures rise steadily until certain points are reached. At these points, the temperature is completely stable at that particular point. And these points, if you check on the graph, are 0 degrees Celsius and 100 degrees Celsius. Remember that because this will come in handy in a moment. So when 0 degrees Celsius is reached, that's the melting point of water. Once melting starts, the temperature stays at 0 until all the ice is melted. When the water starts to boil, which is after it has been heated up until 100 degrees Celsius, that's the boiling point of water, the temperature will stay at 100 until all the water has turned to steam. This is why we know that the melting and boiling points are clear. They're very sharp points and they don't waver. Unless, of course, there is a mixture. Now this means if there are any impurities, it will make the boiling points and melting points of the substance waver a little bit. So for example, if you take normal tap water and then boil it, you will see that its boiling point is not exactly 100 degrees Celsius. It's going to be around 98 or 101. It's not going to be exact, which means that the boiling point of that particular water that you've taken, your sample, has been changed a little bit because of impurities present in the solution.